Okay, this is the continuation of the section 5.5 notes for Algebra 2. And we're learning how to solve equations by factoring. The first step, and I'm going to do it on all four of these, is to get the equation in standard form. And on example 2, all we have to do is bring that 7x back, and you'll get your quadratic up front. Here comes the linear term that we're bringing over from the other side. And your minus 15 comes next, and it equals 0, which is important. So now that one's in standard form, and we're ready to move on to the next problem. We'll come back to this and do the next stage on all of these. Now, example 3, you've got a cubic equation. It's actually got the highest power up front, so that's good. The next highest power next, that's good. And it does say equals 0, that's good. So there really is no work on this stage of getting that into standard form. It's already in standard form. Now, on example 4, what I'm going to suggest is that instead of bringing this back over to the left, which would make it a negative 3x squared, you want to take these over to the other side and keep that as a positive. So your 0 is going to be on the left-hand side, which is okay. It just makes it easier if you don't introduce a negative number at the start. Now, I'm going to show you what it would look like and how to fix it in a minute. But this is what you want, a positive leading coefficient and everything else behind it, either positive or negative. But you don't want a negative in that leading slot if you can avoid it. Okay, so let's just make up a problem here right on the spot. Let's say you ended up with negative 5x squared plus 2x minus 8 equals 0. And you're going, oh no, there's a negative up front. Well, with an equation, you have a luxury that you don't normally have. You can divide both sides by whatever you want. And so if you divide both sides by negative 1, it has the effect of changing all the signs in the problem. So with an equation, you have to have an equal sign before this trick is possible. You can divide this by negative 1, this by negative 1, this by negative 1, and even the 0 by negative 1. But when you do that, all you have to do is just change all the signs in the problem. And so that's how you fix it if you accidentally end up with a negative in the front. Okay, so I just took that little side tour. Now let me get rid of that because that's not part of problem 4. All right, so the next one here, to get it in standard form, we're going to bring the 3 over. And it's going to look like this, 2x squared minus 8x minus 3 equals 0. Okay, so now we're ready to do the next stage on these, which is factoring. And the first type of factoring you always check for is a greatest common factor. The only one that actually has a GCF is problem 3. And so I'm going to take out an 8x out of both of them. Like that. Okay. So we took the greatest common factor out of example 3. There is no greatest common factor in 2, 7, and 15. And there's no common factor in 3, 13, and 4. And likewise in the next one, there's no GCF on that one either. So I'm going to write GCF here with a slash through it. There's no greatest common factor on problem 5. Okay, returning to example 2, what I'm going to do on these problems now is go ahead and finish each one of them. So we've looked for a GCF on example 2. There's no number that divides into 2, 7, and 15. But maybe we can factor it the other way using the star. So I'm going to go ahead and take my leading coefficient and put it on the wings there. And I'm going to multiply 2 times negative 15 to give negative 30. The number underneath it is 7. We're looking for 2 numbers that multiply to give negative 30 and add to give 7. I think 10 and 3 will work really well if we make the 3 negative. So let's see what we have here. 10 times negative 3 is negative 30, and 10 plus negative 3 is 7. So we've got the right numbers here. And while we're at it, we're going to simplify that to 1/5. So the first factor over here is 1x plus 5. That's what the 1/5 helps us find. And on the other side, where you have a fraction that's already simplified, 2 over -3, you just put 2x minus 3. And while we're at it, let's just do a quick check. First times first is 2x squared. You get a 10x and a minus 3x on the outside and the inside. And last times last really does give -15. So we've got the numbers we want. Okay, now you set each of these equal to 0. That's what we learned today. And solve. I'm going to subtract 5 from both sides. So our first answer is -5. Now, it could be -5, or it could be the one we get on this other side over here. So I'm going to see what that gives us. 2x minus 3 equals 0. Add 3 to both sides. And dividing by 2 here gives us an answer of 3/2. So the two answers are -5 and 3/2. And if you would take those numbers and put them in place of the x in the original, one at a time, you don't do both, you'll find that both sides would be equal in the original equation. It would make it true, in other words. Okay, on example 3, we've already got this 8x squared, that 8x factored out of both of the original terms. But this back part here is what's known as a difference of squares. It's got a minus sign between two perfect squares, and it's extremely easy to factor this. You just take the square root of x squared, which is x, and the square root of 4, which is 2, and you use a plus sign and a minus sign, and it works. You can check it. I'm going to go ahead and show you here. There's your x squared. This is your minus 4. And there's no middle term because 2x and minus 2x cancel off. So everything works there. Now you just set these equal to 0. Dividing by 8 here will give our first answer. 0 is our first answer. If you set x plus 2 equal to 0, you'll get x equals -2 as your answer. And over here, x minus 2 equals 0 yields an answer of 2. Okay, example 4, we're going to go ahead and break this apart. We've already checked for a GCF, and there is none. So let's go ahead and set up our little star on the side here. 3 and 3. That's your leading coefficient. And 3 times 4 is 12. So I'll put 12 up there. Right below it is the middle term, -13, or the middle coefficient. So we're looking for two numbers that multiply to give +12 and add up to -13. Well, if you use 1 and 12, you'll get 12, but you don't get -13. However, if you just change the signs of both of them there, now everything works out. The right-hand side goes to 1 over -4 if you simplify that fraction. And so now we know that 0 is equal to 3x minus 1 and 1x minus 4. Okay, we've got it factored. Now it's just setting the factors equal to 0. 3x minus 1, if that were the one that would equal 0, then 3x would equal 1. Took the 1 over the other side. Divide by 3. The other side of this, put or in the middle. X minus 4 equals 0. Take the 4 over, and you get x equals 4. The answers to number 4, or example 4, are 1/3 or 4. And both of those numbers, if you plug them into the original problem, yield a true statement on the original problem. Okay, example 5 is a little different, and I have to show you how to handle this. We've already checked for greatest common factor, so it doesn't factor that way. And I'm going to try doing the star on it. The leading coefficient of 2 goes on the wings. And you multiply the first and last one here, negative 6. So our goal here is to find two numbers that multiply to give negative 6 and add to give negative 8. Well, the only way of getting 6 is 1 times 6 or 2 times 3. That's all we have to work with. Now we can play with the signs. We can change them to positives and negatives. But you can see that this pair would only add up to 7. Or if they're both negative, maybe negative 7. If one of them is negative and one of them is positive, you can get 5, but no combination will give that 8 that we want, that negative 8 that we want. Likewise here, if you take that 2 and that 3, you could get, if they were both positive, they'd add up to 5, or one positive and one negative, you could get it to be 1 or negative 1, or maybe even both negative and you get negative 5, but you can't get that 8. So what this is here is prime. It just doesn't factor. And it doesn't mean there's no answers. That's important. This problem actually has solutions. They're just not the sort of solutions this method will work. So I'm just going to write cannot solve by factoring. It's you're assuming too much when you say there's no solution here. There actually are solutions. It's just this method doesn't help you find those solutions. So that's it for examples 2, 3, 4, and 5, and we'll pick up with another method on page 2, starting with example 6.